Welcome to this session. Today we are talking a lot about the Python integration in JMP, and especially the changes which came in with JMP 18. I will do an introduction to this topic and talk a little bit about the changes and so forth, and why, or the reasoning behind the scenes. And Yamo will then present some examples so that you get some kind of real examples and not just very dummy examples, so that you get some kind of idea of what you could do with that. And then we have a discussion going on with that. Okay, so let's just start. So what has changed? The Python library is now embedded in JMP, so you don't have to tell JMP where is your Python. It is embedded in JMP. So you have a simplified access to Python. It's better maintainable for us, but also you have a Python script editor, which recognize or acknowledge the Python highlighting and as well the syntax. And we have some extended capabilities due to that. For example, if you have Apache Packet files, there are data you can use that Python interface to go there. And so that's just the nutshell. What was before? What was before? There's still the background noise. Yamo, maybe you can unmute again all.
And everyone should be now mute.
Yeah, so hopefully this works now. So in JMP 17 and older versions, you could access Python through JSL with typical things like Python connect, Python init, Python submit, or get, execute, and send. And a simple example is at the bottom, where you have a Python submit statement where you submit something to your Python and then get something back from Python and show it in JMP. That's just one way of doing it. Very simplified. Of course, you could do more than that. However, in JMP 18, you have the functionality through JSL as before, but you have now also the new Python editor where you can have the Python syntax. It recognizes that. And as well, you can use with the import JMP package functionality, which has access to the data table in memory. So you can directly access it. You don't have to send it back and forth. And there's also a JMP utils package, which allows you to use the jpip method, which is a kind of similar thing to the pip method in Python, where you can install your packages and work with that.
You are muted, Martin.
Okay, sorry. Did you hear my previous slide text?
Yeah, maybe just the very last part.
Okay, sorry then. So maybe once again. So JMP 17 and older, we had those typical way through JSL with Python connect, submit, and get, execute, and send typically, and some others. And you see this small example at the bottom left. On the new version, you have this same access through JSL, but also now you have a new Python editor, which acknowledge the Python syntax. And you have several packages like JMP, so import JMP package or import JMP utils package, which allow you to have access directly to the data in memory. So it makes it much easier. You don't have to send data back and forth to the Python. You can just simply work from this JMP environment with the data table with a Python syntax. With the JMP utils package, there is also some methods like jpip, which is the similar thing like pip in Python, where you can install packages you have. But Jump comes with an embedded Python library, which allows you to access directly the Python from within.
Again, muted for some reason.
It's interesting. Okay, so maybe because I returned or something. Okay, thank you. So what has changed, or why did we change, basically? The number one issue we got from and tech support from the users is that it was very difficult to make this Python connection working. You had to specify where is your Python library. You have to specify your packages. You have to check if if you did some programming and you provided to another one, that they had the same version, the same path, that everything is set up in the same way. You had to maintain the whole thing from machine to machine because everyone didn't upgrade to the same version typically. And if they have several packages, some keep them maintained and others not. So there was a lot of issues coming in due to that thing. The other thing is that the JSL editor is unfriendly to Python. As you may saw in the small snippet, it's just highlighting the whole Python code in the same color, which is not really helpful if you are a programmer. And so those were some of those difficulties. There was also not much error reporting from Python. So if there's any issue in your script, you submit it to Python, you basically have to take this whole thing, put it in your Python environment, see if what's not working there. And it was difficult. And you always had to transfer the data or the matrices you work in. And so that's also slowing down your program. So our development had the vision with the feedback from the users that it's just working. You don't have to configure anything. You just want to get that. And therefore, they had an isolated Python 3.11 currently embedded and installed as part of Jump. So it's not necessary anymore for you to bring that information to Jump. Where's your Python? It's just embedded in Jump 18. You have therefore one environment which is common for all users of the same Jump version, and you have the in-memory data transfer, and you don't need to copy and have this buffer access, basically. We want to have a productive environment for Python programmers so that you can have the syntax highlighting, run just the Python script from the script editor. You don't have to embed it into any kind of JSL syntax and so forth and other things. You want to access the Jump data just directly. It was important that it's tested and verified so that this is working, that the general Python integration just works. We support also some in the scripting index now, the Python category, where you can find everything related to Python, and the same thing for the library of packages in Python you have there. You can extend it. Most of them you can just import using the JPEP or install using the JPEP method. Some packages, it's just a very few ones you have maybe to pre-compile before you can install it. Our development did a lot of testing about it. Most of them really is just the typical installation way. And just to be aware, we don't want to provide or create an alternative to JSL. We really want to bring those two worlds closer to each other. So that it's not a burden anymore to use both. If you want to get more information, there's Python-related presentations presented at the Discovery Summit in March in Manchester. Paul Nelson is the main developer for this Python interface. He has written a lot of blogs about that already, and here are some links for his tutorial and for the presentation at the Discovery Summit. And there are also some user presentations which talk about this JMP Python interface or interaction, though they have used JMP 17, so it's not already in the new environment. But if you want to know some use cases, why this makes sense, or when it makes sense, or when you want to do it in a different way, this is something to be aware of. And if you want to learn more in addition, the online help I mentioned already, and in the user community, search for Python, search for, use the discussion if you have questions around it. The community is really active, and also Paul is looking into those questions about Python, because that's basically his baby. And that said, I will hand over to Yamo to show you some examples, which make clear how you can use this and how it works at all. So I stop sharing, and then Yamo, it's your stage.
Yeah, my screen should be visible.
Yeah.
So first we'll go through some basic stuff regarding the integration, and then at the end I do have few examples on the usage. And here I have added links to you so you can run these lines, and it will open. You can remove the JMP window part here. So if you want to open it in your browser, but just so I don't show my browser to all of you, I have used this JMP window so I can easily open these links if I have to. Because especially with the Python, it's very important to learn to read the documentation. So basic documentation, scripting guide. Then some of these posts are the same as Martin has written by, I think most of these are by Paul Nelson, but some might be by someone else. And then presentations from Discovery Summit, few of those. But check this out if you're interested in the integration. So I think one of these also has some additional examples that you cannot find with the JMP installation. Few initial things before I go to the integration. From JMP side, it's not easy to figure out where the Python is installed. So it requires some sort of works in Windows, at least this. I have here, I think it might be different in Mac, but it's in Windows in app data, roaming, JMP Python. So in this case, I have JMP Pro, but still it's in JMP folder. You have separate function, and I think this is most likely the preferred method. You can have this Python constant from a JMP package that you can use over JMP module, and it will give you the same path. Then scripting index. So you have on JMP side, you have the Python category or Python group. Quite a few of these have been are obsolete. So you will see here deprecated. Check from scripting index. Few of them still work. Some of them are deprecated. So if you are using 17, most likely, I'm not sure if any of the scripts will work easily, and you should check them and move them into 18. Then separate section for Python. This is a completely separate category. You can see it from here. Different objects and so on here explained. Some examples for JMP utils also. Scripting guide, I showed in the beginning. Then there is also, these are Python commands. So Python has this help command. This will print, if you run this command in JMP, it will print to the log, basically information regarding, in this case, JMP packages data table object. So it will display information, what type of methods it has and functions and so on. If you want to have it in a bit cleaner format, you can use PyDoc and, for example, print it to a new JMP window. Similar information. This can be good to read because you will face these when you are going through Python documentation. And then there is also this sample script pyen.py that does print a lot of stuff to log. This has, I think, most of the things you can see with the Python. It's not just limited to the data table object. It also has information regarding the data types and modeling types. And then I think it also has the constants at the top or somewhere. There are a lot of those. Jump credit examples, you can find them from sample scripts. So here you have a few examples. And also, like I mentioned here, if you go to this presentation by Paul Nelson, few additional ones can be found from here. In this case, in this presentation, I have 3 sections: JSL to Python, Python to JSL, and finally examples. So I will, in this JSL to Python, I will cover a few basic functions. So we have Python get. It's used to get data from Python to jump side. Python submit is used to submit statements to the Python. And because we are in jump 18, it will work directly in the jump, and you will have the without any hassle. At least in my case, I haven't faced any bigger issues outside of some package installations. So in this case, I can move this. I have my Python. I have my own theme for the Python. Jump doesn't, at least I didn't figure out if it has dark theme. I created my own. So I will run this code on jump side here using Python submit. And then I don't have access to these variables. They are only in the jump, Python side. So I can now use Python get to get the values back to jump. So if I run this, it will print those here. So Python get is to get some data back from Python side. Then with Booleans, you don't, even if this is coded as true, you don't usually see this in jump. I think earlier it was only used with JSONs, but usually it shouldn't be a problem. You can check this out if you really want to see how it behaves, but it should work just fine, the Booleans. If you want to create them in jump, as Boolean does create this type of value. If you write it like this, it will be an error. With Python submit, you can also use a list of commands. So in this case, I have set string val to ABC number 1999. Then I have one print here and then multi-line print. And if I run this, it will execute all of those. So it will replace string val with ABC and number with 999 and then print the values. This is the first print. I'm using Python's F strings here, so I can get it in this type of looks a little bit like jumps show would show it, and I don't have to start writing these out separately. A good way to print values in Python for some debugging, for example. Then you can use, to get from the data frame to jump table, you can use, this is basically a direct conversion. So in this case, I will move this again here so you can see the Python highlighting or syntax. I create a pandas data frame here, and it should print. It takes some time to initialize the pandas. It will print the first 10 lines of the data frame and then some information or column information. You can use Python get directly with the data frame, but if I try to see it from the new window, it's not here. It is because this is a private window. So I can use make new data view to convert it back, make it visible. But this is using most likely older method. It is using temporary file. It goes through CSV. It first saves as temporary CSV and then loads the CSV to jump. But this is very quick way. You can just use the get from the data frame and get it here. But then they are completely separate because it's basically a copy. If I close, or did I already closed it in jump. So if I now print it in Python side, it's still there. So it's in Python memory. Then we have Python send. It's used to send data to Python. So I initialize a list in jump X. I use Python send to send it to Python. This Python send, I think it always returns a 0. Then I submit, so I submit some sort of command to Python. In this case, I set y to x plus x. And now here I can use Python get to print them in jump side. And I could also print them on Python side by sending Python submit. So you can work quite easily with this. Of course, this does not have, this is just a string. It doesn't have Python highlighting. You can also send data tables directly to Python. And in Python, they will look like this if you print them by default. Scoping operators, in this case, first colons, and then double colons, and then some jump names. Jump has very flexible naming for the variables, so you can have white space, hashtags, and some other special characters. So if I try to, this works just fine in Jump, but if I send it to Python, I'm not sure what happens in the background because there's no error. It returns the 0. But if I try to print this, it's an invalid syntax because Python doesn't allow you to have white space in the variable names. You can of course fix them in Jump side. I use this type of formatting in my code. I never leave these white spaces here. And now if I send it to Python, it works just fine. But Jump does do some conversion itself. For example, if you use have this one colon here, like in this case, I have here scope and then global scope. In this case, if it's just a here scope and I send it here, it doesn't exist because this is not allowed. But Jump Python integration will replace it with underscore. And one thing to note, just a thing here it can cause issues with some modules. This seems to be integer, but in Python side, it's turned into float. You might want to convert these into int, depending what you are doing. Then if you have global variables, again, doesn't exist. And basically these type of variables do not exist in the Python side. This is just ignored. Then if you want to modify the names directly, Python send allows you to use this type of named parameter Python name. So in this case, I will send jump var name, but this will rename it on the Python side to Python var name. And then you can, I think this is mostly used to see how these variables would look or some sort of conversion. Python jump name to Python name. I'm not sure how useful it is because it doesn't work, for example, with this, but you can check how it would perform a conversion. Then I think this is the, when you start working with anything more complicated, Python execute is the most likely the one you want to use most. It allows you to send to Python input list of inputs, and you can get back a list of outputs, and then you can execute statements. So I have jump variable AAAA, and it's just a string. So it's this first one, input parameters or inputs. This is outputs, and this is the Python statement. So it should basically concatenate this into the B. So if I run these, you can see that Python has concatenated this together. This is a more a longer example. I think this is from Jump documentation. So it just creates some values in Jump, and then it runs some matrix calculations using NumPy and the Python side. And here it's a list, get list, many inputs back, and then a bit longer Python code here. I don't go through what it does, but it will replace, for example, this X here. It will be replaced because this is here. But you don't have to initialize these, like in this case, I didn't initialize the BBB at all, but it still did work. Then you have Python send file. So you can send data files to Python from the path. So in this case, it sends big class jump, and it will convert it into a data frame directly. By default, it is reliant on the name. So most likely it will just replace this. I'm not sure how it works, and if I have multiple similarly named tables, what would happen. But I can access it, get it back to jump, because the variable name will be this one. And if you don't believe me, it's open here. But you can use Python name to define the variable name. If you use Python send file, I would always suggest that you use this, so you know what variable you will get back. So my DT is basically this table here. And then I can use Python get to get the my DT to my DT and jump side, and then close. And then Python submit file, you can send statements in a Python file directly to execute on the Python side. So this is the I run earlier Py environment. It will print most of the stuff you can do in Jump or Jump specific things in the Jump modules into the log, and also open up a single table. Quick recap of these. So Python submit to submit statements, get and send to send data to Python, get data from Python. These do perform data type conversions, check them from the documentations, and they are not the same with the get and send. So it's a good idea to check what is supported and what is turned into what. You can see it from the scripting guide. Execute, send list of inputs, statements, and a statement, and then get a list back. Sending files, and then the data files, and then also Python files. Yeah, so I start again from here. So Python indices start from 0 in Jump, mostly from 1. There are some cases where they do start from 0, but not many. Using this integration on the Python side, also in Jump side, does require knowledge of Python. And due to this, you have to know how to find the documentation all over the internet. You don't have scripting index like you have in Jump. And there's no that type of interactivity, like I can hold Alt and click here to open scripting index. Check out these examples. Some are very good examples what you can do and how you should do some stuff. And this is just an example of the Python environment script that is there as an example in the example files. So this is the file that will be executed, and this is now with the Python syntax highlighting. And these are basically shows all the different constants you have. It runs help command for multiple different objects that are Jump module specific and so on. And this is then the log. You will get the script so you can check how these are. Run this yourself. This is my support function, just to make the presentation a bit easier. There is also own syntax reference for Python in the help, Python syntax reference, and it explains all the different packages and then the objects you have. So most likely most of these have some sort of examples or idea, fairly good idea how this can be used. So let's see. So now I will copy paste this because it will otherwise print to here to log. So now these are just very simple example from the Python. And this is now my Python. It's a bit different background color than I have in my Jump. And also these are most like the best indicator, but which script territory I'm working on. So constants, you can find this from scripting index, Jump version, Jump temp, and so on. And this is a pure Python syntax, so end just to make it a bit cleaner. Again, scripting index. So these are basically what you can find when you go directly to Jump version. It's here. And then explanation in the scripting index. Data types and modeling types from that the Jump package or module has. So you have these members in the numeric character rows, that the expression, and for modeling type. These. Then in the Jump package or module, you have Jump open. So it will open a Jump table, or I think you could also CSV, Excel file, and so on. If it's able to open it, it will return a reference to the table. Otherwise, it's a true or false. So when I run this, it will open the table in Jump. Jump current is the same as current data table, so I can get the reference. So it will print that table. And then Jump table, so you can use the name to get the reference or access the table. So it will print the same thing here. Then you can run Python from Jump, but you can run Jump from Python. So this is basically the if you want to do something that and you cannot do it with the jump package, this is the way you can basically force it to happen. So this is very simple jump script. We can run it here first. So let's add this here. So it just opens big class table and creates then a graph builder. Is what this script does. And I can run it from here using run JSL. It does exactly the same thing. Few things regarding data table object. So open table, and then you have this. You can send or use these to get name, number of rows, number of columns. You can see what is either from the help or then from the scripting index, whatever you have access to. The jump table is an iteratable, so you can basically use for and go over it, and every time it will return or it will iterate. It will return an iterator, which is the column. So in this case, I loop over dt, store the iterator to call name, and I print the call name, and these are what I get. And these are most likely jump column. These are jump column type objects. And they do have, let's see, yeah, so, and then you can access them using name, index, or so on. And this is just extra print from them. So what they contain. If you check the data type, so this is jump package, data type character, and so on. Some examples what you can do with this. Then to the installation of packages, sometimes it is very easy. So you can use jump command, Python install packages. This will install pandas. It can be very easy also in Python side. And this is example in the scripting index. So import jump. I don't think you don't need this. I think this should be enough. Import jump utils and then run jump utils jpip, and it will install it. Or try to install them. Sometimes it can be manageable. Like, for example, I have one example here that is not that easy to install because it's a compiled Python package. But the documentation has some stuff that might help you. So check this out. So basic cases, installing compiled packages using command line and jpip. And then there is this where you might have to package them yourself. But I think in the end I have managed to install all of the packages on some level. Some problems from time to time, but still it's a normal case with programming. You will run into issues and then it's just debugging. Now I start with the examples. I will mostly go from JSL to Python because this is jump scripting, not Python user group. And in my case, usually, at least I think what I will use the Python integration mostly is to enhance jump in some way. I don't see myself doing that much, like going from Python to jump. I go from jump side to Python, do something, and then come back to jump. Here is one example. This is the ready example you can find from here, how you can go from data table to Python data frame and then back. And then there is the quick example I showed with the CSV, but this is I think this is most likely by Paul Nelson, and this has good explanation. And then you can see here is, for example, the CSV transform. But I have a bit different. I mostly started, I had used this a little bit, but I did this in yesterday and today, most of these examples. So to go from so this is to pandas data frame. We need jump, numpy, pandas. So we have jump table open. I'll close these extra tables. And this is one nice thing here with the jump integration that you can basically just, no idea it opens twice. But this is one nice thing that you can run this like in Jupyter, single lines. You can be a bit annoying in Python if you always have to run the whole code. but you can do it one line at a time. Not in every case. There are some issues with the white space, but usually you can do it like this. Then you can initialize a data frame, loop over it, all the columns. I think in this case, we should be able to run. Oh, we don't. These we have to print. Not as easy as it would be in JMP side. Loop it. I check some data types. So if it's a character or numeric, it's okay. Else it's not converted. Convert the values into list, and then you can add the list to data frame. So we should end up with a data frame. Now, so these are a few basic commands you can check how the data frame looks. So now we have a data frame in Pandas data frame with column, name, age, sex, height, and how many values they have and what types they are. And this is an example of the data using the head command. I can print. Okay, it's still the same, but I can print few lines from there to quick check that everything is correct. Then if you want to go from Pandas data frame to JMP table, it is basically the same idea. In this case, I use Seaborn just so I can get access to a data set. I could do it, open a JMP table, but I want to use just a pure Python package in this case to build the data set for me. So now I have Iris data set here. So it's most likely exactly the same as JMP has. I can print more information if I need to. And then it's again, you loop over the file and create the columns and fill them as you go. You can check it from here. What is the idea? But I use for loop enumerate so I can get the index. Most likely I can drop. I don't need the index here. I can just use the name. I check the types. So in this case, if it's a float or int 64, then I will create a numeric continuous column. And if it's an object, I will create a character column. This would have to be made a bit more robust, but for a basic example, it should work just fine. There are, for example, datetime and Boolean. At least datetime might require additional handling. I'm not sure how the conversion would work. And then create a column, and then you add the values. The examples in the sample script has different way of doing this. I just tried this and it works. So this looks a bit more simple than the. Let's see if I can find. Okay, let's see in the end if I can find it. But it using an ilog and so on. It's not a difficult thing if you know Pandas data frames, but otherwise it can be a bit difficult to read. But it's not too. I think these methods are or some similar methods are the way you should do it. Don't use the old method of going through CSV unless you want to do some quick stuff. Then I would say it's fine. Most likely, best idea is to write some sort of function so you can use this easily many times. Then there was this type. Next example, getting images from Python. There was Python get graphics. I haven't used it. No idea how well it worked, but it has been deprecated now. So you cannot use it. If you try to use it, it will say to save the file and open the file. And here is an example for it. First, I clean the paths and create the path. So I will send save path to Python. Paths can be a bit annoying sometimes working with Windows and Python. And then I use, in this case, I have to run it here, but here you can see the code. I use Python submit to send the code. And then I will save the figure to the save path. So here, and then I will open it. And when you use open, JMP will open it as an image. So now it's here, and I can run this here. I don't have the save path on here, but if I run this, it's the same, but now it's in Python side. But you don't have to do the saving if you want to avoid it. You can use IO buffer in Python. So here I use I get the image. Basically here the image is, have the image here. But I have added few extra packages or modules, base64 and IO. And then I basically save the image to IO buffer. And I can convert the IO buffer into base64. And then I can use jumps character to blob function in jump side to convert the base64 back to an image. This is one thing you, for example, if you want to embed HTML images from jump to HTML web page, this is one thing you can do. So build base64, and then when you add that to HTML, it will be visible. I will add the embedded HTML blog post here. But now I don't save the file it's just in the memory. And it works just fine. So it's an IO, and this does have some other use cases also. And if I run this print here, you can see. So it's a long string, so base64 basically. So it's a combination of Python commands and then in jump side char to blob, so I can convert that string back to an image. Then I think this is the biggest, these last two are the biggest use cases I will have for the Python. So running some sort of analysis or platform that Jump doesn't have. This example here does require Jump Pro, but you could use this UMAP, write a Python code to run this method. But I think this is Python Jump Pro method multivariate embedding. So this is now I start from Jump side. I open the iris table. I clear row states because this will otherwise have colors, which will immediately tell which species they are. I run UMAP to perform dimensional reduction. Let's not close that. So now I have two dimensions from these. Then I will use Python's HDB scan module to cluster these based on these two here. So this is the Python code. Again, I can move it to here. Might be a bit easier to see. You can check it from the HDB scan documentation what these mean. And this is very hard coded code. So I fixed the indexing here and so on, but it's fairly easy to modify it so it's a robust script. So what this does, it adds me a cluster, new column, which is basically the clusters I get from HDB scan. So we should get a new column here when I run this. So I sent the data table, perform the analysis on Python side, and then I get the clusters back. Then you could also just get this is a list you get back. You could just use the list with Python get, but I just use the added in the Python side to already the jump table. And this is the other method you can use, the list ilog instead of the get values I used earlier. Then I can visualize it here. So it seems like it, in this case, I might have selected UMAP on purpose, so it works. It clustered these fairly well. They are not exactly correct, but they are, okay, they are not the same as species, but the cluster seems to be quite nice. But this is something that Jump doesn't at the moment have. And then I have also a full demo here. So this goes a bit deeper. So I have a user interface. Sorry, let me close this. So this is something I will be most likely doing quite a lot coming years. So this will first perform dimensional reduction, and this is done on Jump side. So UMAP or TSNE, I will use the UMAP. I can modify parameters which will be sent to Python. When I run this, it will create me a UMAP and clusters. I leave this open on purpose, so I can now modify this, run this again. So it's a different graph, different algorithms, different clustering. So you can do stuff like this in Jump. I have all the tables here or columns here. This doesn't work correctly. It should create a separate column group for all of the analysis I run. Then, because Jump tables do have pretty nice column properties, I have added the nodes here. So this now tells me which HDB scan basically cluster size and samples I did use. So I can go and check them from here. would be a good idea to add the HTTP scan, maybe runtime and so on also. But it's utilizing, going very deep from basically building a custom platform partially to JMP using the integration. And this is, it will be a bit even longer code, but it's not that difficult. And Python side is basically here. Okay, these belong to Python side, sending variables to Python. So I do have some time to check this. So in this case, just demonstration purpose, I had the table open, check a table. If not table, throw an error. If JMP is not a pro, throw an error because the UMAP and TSNE require pro. After those, I initialize the Python because this takes some time, so I don't want to do it here before these have been checked. Some expressions which will be executed when user presses the OK button. So first run dimension reduction, whatever happens there, clustering. So this is the Python side basically, and then some JMP here to create the add the nodes and grouping of the columns, and finally some simple graph builder, and then save that to the data table. I don't have it open. I can also show that. So now I also, okay, yeah, I maybe didn't run it. I'll have to check it if it didn't run it. But basically, this is type of, you can utilize the integration now to build new platforms to JMP, which JMP doesn't yet have, or enhance some existing platforms. Other example, let's see. So this is now like the Parquet example. So in this case, this is a LabVIEW or National Instruments test file. I have tried to write a JSL for this, but JMP's DLL support is not good enough to handle the type of data that we have here. So there is a package in Python, nptdms, you can use. So I use JMP to pick a file. This is some sort of example I found from the internet. I haven't checked how much more I would have to do with the file to get it in a correct format. But I use JMP, so user can pick a file. And if you pick a file, always check that user did select the file, clean the path, so drop this first one from here, and then I built the string. I can use then, I could build this, most likely I would build this on Python and then use Python send or submit the code to Python. But here I have a script which will open that TDMS file, parse the file, and then turn it into a JMP table. And then I can use Python execute. And in this case, I use the Python execute, so I can provide Python with the file path. It's used here to open the file, and I will get back the reference to data table. And this is the string here. This will take some time to build the table. But most likely it will require a bit more because how complicated the file is. But now I have the TDMS file in JMP. You could earlier use Excel plugin to do this, but it required you to have admin access to PC and so on. But this depends how complicated it will be to clean these if you are more complicated files. But mostly you can do it in Python and then get the fairly clean back to JMP. And then this is final one. You can get, there's a pretty good example, an explanation by Paul regarding this. So you can create JSL functions which basically use the Python, and user has no information, user doesn't really see that what is going on, that it's performing everything in Python side. So here I have my function. It has 2 arguments, and inside it has a Python code. It basically creates my func inside the Python side. Again, 2 arguments, and then inside this JMP function, I use Python execute, so I can easily use these arguments as an input to the Python function, and I get the result back. And this is the final. This has been already initialized inside the Python due to Python submit, and then with the execute, I send this additional statement to Python. And because in Python you can use the plus to create a lot of combine many different things. So I can run it with numbers, characters, and lists. These results basically come from the Python. And then you can go a bit silly with this type of Python execute stuff and start building overly complicated stuff if you use argv and quarks. So you can evaluate stuff inside here, and you don't really need to know how many arguments user pass in. But this, most likely this will start getting, is something that you don't want to do unless in some very specific cases. But these do have use cases because you don't always know how many arguments user will pass in. But these are just simple scripts that, let's see, so evaluate some arguments here. Okay, they are already evaluated here. And then it will just print the next value basically. But this is also Python specific thing, so check the documentation, what these mean and how they should be utilized.